Good day, good day. Alright, let's just do a quick audio check real quick. Looks good. There she goes, on screen. I'm just gonna go grab a drink real quick. Yellow, yellow. Alright. I'm doing pretty good, how are you? I I don't know. That was hilarious actually. That was yeah, one of the best spelling errors that I have ever seen. Also, it would help if I actually pulled my chat up on my stream monitor here. So, allow me. Yeah, so I can actually play the game and not continuously be alt tab the whole time. There we go. So lots of documentation that I've got pulled up for this. This is completely going in blind with RTCC, so I hope I'm doing it right. We've got a couple of hours just of time skipping real quick. I always give myself a few hours because it gives, as people come in, like it gives people something interesting to look at within the first few moments, gives us all time to take it in what we're really doing, and it gives me a little time to mentally map out how exactly I'm going to do this stuff. I've of course powered up the LEM and I've done this mission dozens of times. However, this is the first time that I will be making my own calculations for everything, doing all my own uplinks with the RTCC. So you'll have to excuse me if something is wrong. Um, yeah, we're not going to be landing today because the LEM power-up takes so long, but we're going in completely blind, so we'll take it piece by piece at a time. We are currently at 89 hours, 30 minutes. We will begin wake up at 94 hours, so we've got just a little bit more time skipping to do. About 4 more minutes of time skipping. 4 minutes, 15 seconds. So if anyone has any questions, now is the time. It's going to get pretty intense. We're going to get down into the nitty-gritty of the engineering of the lunar module with a full power-up. So it should be exciting. No, it does not. And thankfully, all the astronauts paid their taxes this mission, so unlike Apollo 10, we can pay for abort propellant necessary to lift off of the moon. Because funny thing about Apollo 10, it was never a landing mission, but it carried enough descent propulsion fuel to actually land on the moon. However, it did not carry enough ascent propulsion to actually lift off of the moon. So the joke in Apollo 10 was that the astronauts didn't pay their taxes and therefore didn't get any abort propellant. T plus 92 hours, about 2 hours till wake up, so 2 minutes real time. And then we'll pop us down to real time. We'll do some housekeeping, starting off with a stir on our cryo tanks, both H2 and O2. We'll do a GDC align if necessary. We'll activate our comms for the wake-up period. We'll regain attitude control of our spacecraft, and we will roll to our fixed attitude. We'll calculate an emergency abort pad, and then we will start boarding the lunar module. So it should be a good time. About 1 more minute, and then we'll get started. So who's excited? Who's excited to see? Never before have you seen a craft powered up from cold and dark during the middle of its flight. Like, could you imagine just like spawning a 737 in midair and being like, okay, time to turn this thing on now? Yeah, that's essentially what this is like. Okay, Apollo 11, good morning. Let's start with our cryo stir. While we're getting a cryo stir, I'm going to write down those coordinates for the P-22. So AOS is at 35 degrees. So P-22 AOS is 35 degrees. Good day, James. I think gravity would disagree. Well, that's fair. That's fair. Okay. How's our GDC looking? Remarkably well aligned. We will make no further corrections to that. And we'll get on the normal comm configuration here so we can talk to Houston. S-band, Omni Bravo, tape recorder, forward off. Potable water heater is on. High gain antenna track. Manual, wide. Yeah, that's a more close approximation. It's like, yeah, that's a good one. It's like if the train had the complexity of a plane and you turned it on while it was still going 80 miles an hour. That's more like it. That's a good one. Okay. So we had acquisition at oh, this is landmark ID. Landmark ID 130. Predicted acquisition would be at 984508. It's a 9.6 nautical miles north. But the most important information to make our calculations on this are 1.243 degrees north latitude, 11.844 times 2. 23.688, 23.688 west longitude, and a predicted altitude of minus 1.46 nautical miles. Uh, who is this person? Ah, a War Thunder player. That explains a lot. I mean, I don't particularly mind at all. Alright, we've got attitude control. Let's go ahead and enter our wide deadband hold here. And then let's look for, at the same time, we'll need our TEI 30 pad. So TEI 30 is predicted to be at 135 hours, 24 minutes, and 40 seconds. Two jets, ullage, so delta X is 3217.8. Delta Y is 0603.6. Delta Z is minus 0130.4. 2 jets for 16 seconds. And this is based on LOI refs mat. I mean, First Amendment, people could talk how they want to talk. That does not particularly bother me as long as they're not harassing anyone. I mean, there's no reason to delete these messages. Okay, let's go ahead and make our abort calculations. Yes, I do remember. You requested SSM 2007. We'll get to that. We'll get to that. There's so much stuff to do in Apollo that people keep asking. So we'll get to SSM at some point. Yeah, I was gonna say, furry speak is not really inappropriate as much as it is cringy. Like, I totally get where you're coming from, but at the same time, it's not really harassing anyone, it's not making dirty jokes, it's not, you know, those are the things I actually care about. Alright. Phyto mission planning table. Okay, make this just slightly bigger. Alright, maneuver targeting, general purpose maneuver. Nope, excuse me, not that. Return to Earth. Technically, it's harassing my eyes and brain. Oh my god, that's funny. Abort scan table, specific site MPL. We will integrate vectors at 135. Let's do 10, just to give ourselves like a nice 10-minute leeway. Time of ignition will be 135, 24, and we'll just cap off the seconds. Okay. So the delta V, we can estimate time of return. Let's do 135 plus 24 by, let's go like 2.5. So 195, 24. And let's see where that gets us. Okay, that's probably not enough time. Let's do 135 plus 24. 24 times 3. So let's just start with 207 and see where that leads us. Okay. We may need to lift the constraint. VR max. VR max. Instead of 36323, let's go with, this is column 1. VR max. Let's go 37200. And let's try that. Okay, still no calculation. We will go ahead and here, let's go. Let's do a lunar search. Let's go 134 to 136. TZ time. We'll predict that to be 2.5 days again, so that was 195. $24. There we go. So lunar search did definitely work. We've got a GETI of 135.32. 22. Yeah, I don't play gacha games. I hate gacha games. I don't like anything like that. Like it's all super cringe. So there's two. So this is kind of hard to explain, but there's 3 things that go through the S-band antenna. 2 of the main things are an uplink and a downlink, and then the third is for aux. When you get the uplink initially is just like a signal broadcasting constantly. And then the downlink contains the transponder information. So it's making that transponder beam physically narrow out. And when you narrow that beam out, you basically point, like you have to point more center, like just tiny adjustment. And then the narrowing makes the signal better. That's the best way I could really describe it. So we did get a lunar search, and let's go ahead and do return to Earth constant 101 current refs mat. C sucks. This, let me see if this assumes undocked or not real quick. It looks like it assumes docked. So it would be CSDX, 2 jets for 16 seconds. Heads down, iterate, display, calculate. So let's go ahead and transfer. M74, CSM, return to Earth primary. Pad, calculate. So delta X is 3221.8 plus 705.4 minus 11.6. That's really close to the real life parameters. So I'm gonna go ahead and take that. Okay, now that that's done, we can get this all out of here. So we can go ahead and delete M62, CSM, maneuver 1, delete, no vector. Gone, gone. Alright, let's get in with it. We did that calculation slightly early, but that's no worries. The earlier the better, because it's about to get really hectic. Small attitude maneuver here. That's some small adjustment. Five people in chat, 4 watching. I see 5 watching. Yeah, YouTube is a little goofy. Spacecraft attitude's a little goofy as well. I think we'll actually let it stabilize better. Okay, there we go. We'll leave it in minimum deadband hold for a little bit while we stabilize. Alright, that's better. Okay, H2 purge line heater on. Let's start boarding the lunar module. Those two things have nothing to do with each other. But, just purging is coming up very shortly. Okay, LMCM delta pressure. Delta pressure should be very close to 0. Tunnel lights on. Lunar module pilot, intervehicular transfer to lunar module. And let's go ahead and connect the CSM02 hose and switch over. Ah, yes. Welcome into the lunar module. Lunar module pilot still has not, of course, ingressed the vehicle yet. They're working on opening the hatch right now. Well, this is your sort of sneak peek if you haven't seen the inside of this baby before. This is my favorite spacecraft, actually. Well, we're just in here. The lunar module pilot is currently taking a ratchet, a torque tool to, what are they called? A ratchet wrench. And is currently working on opening the hatch on the other side. And then they open it, and the opened hatch disengages a switch which turns on the lights, even though the switch for the lights is not on. It's an override switch. Let's go ahead and add the lunar module pilot to the cabin. And this is the switch that will actually keep the lights on after the hatch is closed. Let's get some utility lightings. And they're not currently modeled, but we'll just go ahead and get them to dim. Just for realism on the power draw of the spacecraft. Descent O2 open, descent H2O open, cabin repress to auto, cabin repress circuit breaker closed. We can go ahead and take down the window shades, have a look outside, see that our landing gear is not deployed. And get a fuel cell purge going. Gotta keep our power plant healthy. Very important. Lest we lose fuel cells and very rapidly start running out of power, which is something that will happen if we don't do this procedure. Okay, fuel cell purge complete. AH2 line heater off, and back to the LEM. And back to the CM. That was just a message telling us to make a switch over to lunar module power, which we will be doing very shortly. Okay. LEM power reset. Okay, lunar module is now on its own internal power. Let's get the translunar bus tie. There we go. Translunar bus is on. And back to the command module. So we're looking at minus 33 plus 262. Good signal. Lock it in. Okay. Ooh. 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 Take a screenshot of that real quick. Okay. So next up on our list, I'll just show you guys. We've got, in just a couple seconds, we'll activate our electrical system, get the mission timer rolling, we'll get some cooling going, and we'll do, of course, the best test ever, a test of all of the alarms and lights and bells and whistles. We'll get the evaporator going, and we'll get all our circuit breakers plugged in. So that's what's coming up very shortly. Lunar surface is looking great. All right. Annunciator and numerics and integral lighting to max bright. Instrumentation, signal conditioner 1 closed. Electrical power system, decent ECA control closed. Instrumentation will need signal sensor, telemetry, and signal conditioner 2. We'll need our EPS display. We've got our talkbacks and our decent ECA control. S-band we will transceive on, intercom we will transceive on. Circuit breaker comms, display closed. System engineer audio. Let's get our transponder going. And we'll need the antennas up for that and the pre-modulation processor. And let's actually send power to the transponder. We'll go down voice backup, pulse code modulator, telemetry bitrate low, S-band antenna aft. And we'll get a signal lock in a few moments. While waiting on signal lock, we'll verify talkbacks are low. And we are going to start switching to the high voltage. So cross tie, balance loads open. And let's make the high voltage switch over. Okay. And let's balance load. Load is balanced. Excuse me, not balancing load yet. We're cross tie bus closed. There we go. And let's get some AC power going. Okay, we've got AC. Let's get our mission timer. I'll need AC bus B, numerical lighting, and flight displays mission timer. Oh, someone broke some glass. All right, circuit breaker, ECS display closed. Let's check out pump 1, instrumentation only, pump. Temperatures, of course, are a little high and the pressures are a little low because we are not running any pumps at the time. Auto transfer closed. Pump 1 close. Auto transfer open. Glycol pump 1 selected. Pump 2 circuit breaker close. Auto transfer close. Okay, caution and warning checkout. Sounds about right. Okay, here's all of our alarm conditions. We got alarms on ascent pressure, CES, AC, DC, lunar guidance computer, RCS regulators A and B. We've got alarms for preamp conditions, heater trouble, and environmental control system trouble. We've got a component for the water separator. Let's start getting our reaction control system preheated. Rendezvous radar is just slightly cold. It goes without saying as we've been powered down. Landing radar is at its minimum operational temp. Quads 1, 2, 3, and 4 are obviously below their operation temperature, which is anywhere between here and here. And the S-band is at its good operating temperature already. Heater light is out. We've acknowledged the alarm by just clicking through and checking everything. Verify 2 lights and tone. Verify bank 1. Verify engine push button and bank 2. Yeah. Verify bank 3 and bank 4. Now we'll do the Christmas tree. Because this bus is currently unpowered, we don't get that light for the lunar contact, but we will later. We get this light, though. We get those lights, and we get these lights, okay? So a Christmas tree test is good. And back to off. Sublimator is up, and let's get circuit breakers going in. Okay, we've got integrals. Okay, circuit breakers are in. Let's recycle. Hack the heater alarm. Gray, 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 barber pole. All barber pole, all gray, barber pole, gray and gray. Recorder, barber pole. Very good. Alright. Circuit breakers are in. How entertaining was that? It's kind of satisfying, you know, just click, 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 click. Wonder if that's what Stumps feels like when he gets to plug in all the circuit breakers after his airplanes are now airworthy again. Okay, so now we do the fun part. Let's go ahead and make a save. So first thing on the roster is the landmark tracking. So let's go ahead and get the MPT initialized again. Just so that we could do landmark tracking. Present time, 35 degrees. Landmark is at 1.243. And 11.844 by 3, or by 2 is 23.688. Calculate. There we go. There's our prediction for that. I'm going to go ahead and record that down. Starting up a DE. Yeah, DE trains are kind of nice. Okay. Next up is a refsmat, uplink, and CSM state vector. So let's go ahead and get utility, refsmat. Option is going to be landing site. This should be... I should not need to make any changes, but let me just ask real quick. Let me just ask, and I'll pause too. At Captain. I don't need to make any changes to LF's refs settings due to it being a pre-made scenario. Correct. Let's see what they say. I'm very positive that I don't need to because it's just taken from the autofill to preset in a scenario file, but I'm asking just in case. Landing site 102, 47, 11, latitude, longitude. It looks good. Okay, they said it should be good. So here we go. Let's go ahead and calculate. We've got it. Just to verify. Yep, it did actually change. Okay. Uplinks. Starting with the CSM navigation update. Let's go ahead and go poo and accept. Okay, and a refs mat update. We'll take our current address and we'll move it to the desired refs mat location in the computer. Uplink. So just verifying that all these numbers here are coming into the computer display properly. And it looks like we're pretty good on that. 40424, 73042, 42522. Good. Uplink complete. Refresh. And copy our CSM state vector to our LEM state vector. And then we'll just go ahead and nab ourselves a DAP pad. And instead of taking a photo, I'm just going to write this one down. CSM DAP is plus 37739 on the weight. Plus 33773 on the LEM weight. Plus 001.49 on pitch trim, and minus 000.64 on the yaw trim. I don't think we'll need the trim, but it's given, so we'll write it down. And that should be everything we'll need. We'll keep the MPT initialized, but we'll just deactivate that for now. And Commander intervehicular transfer. A burrito is not Mexican sushi because burritos are cooked. Good try, though. Good try. Tartar is akin to sushi, although it's not rolled. So I guess you could say it's more like a sashimi. Okay. The computer was a marvel of innovation. I agree. I love this thing. Alright, time to turn on the computer. Verb 36, enter. Verb 21, noun 01, enter. 3000, enter. 2343, enter. Enter. 333, enter. 10000, enter. IMU operate closed. I mean, this computer was a marvel of engineering too. But we'll talk about that later. Okay, no attitude light off. Christmas tree test. Reset. Verb 37, enter. 00, enter. Verb 25, noun 01, enter. 1365, enter. Enter, enter, enter. Verb 15, noun 01, enter. 1365, enter. Verb 21, noun 27, enter. 10, enter. Register 2 will be greater than or equal to register 3 within 78 seconds. We'll wait one more count just to verify. Looks good. Verb 21, noun 27, enter, 0, enter. ECS activation, so just make sure we've got, a full tank here. Yep, full O2, full H2O, looking good. Let's test to make sure that we can do our suit isolation system. Looks good. Pressure regulator A to egress. Suit fan 2, followed by blaring alarm. And within 2 minutes, we should see the H2O separator light come off. Any questions so far? It's a pretty simple startup. Nothing too crazy, really. Okay. H2O sep light is off. Suit fan to open. Alarm. Alarm. Okay, suit fan 1 closed. Separator push for 1. Suit fan 1 on. And circuit breaker suit fan 2 close. Verify high voltage taps. And we can go ahead and balance the load now. You can see CDR bus is taking on less of a load, so we'll go ahead and... There we go. Let's go ahead and get our secondary test going. So we got, it's pretty bad signal strength, but we'll go ahead and proceed with the secondary test anyways. We got relock and a good voice check. Back to mains. Relock, there we go. Nuke, we have to hear you speaking German. Never. Are the background sounds what the astronauts actually heard on? Is that accurate? We believe it to be accurate, yes. How accurate, we don't know, but the sounds are described in the Apollo Operations Handbook, and we believe them to be as accurate as one could be with the sounds. Okay, S-band antenna looks good. Let's go primary voice. Off reset, telemetry biomed left. And let's go ahead and check a steerable. This is an antenna in which we can actually see it function. It's this one right here. So let's go ahead, 2550, set to slew. And we could see her turning around. Do a barrel roll. Okay, pitch to 175. Yaw to -5. We can see she's pointing good. Now we'll go and select the steerable. We do have a good phase lock. Let's engage the auto track and see we enable, which will cause a VHF ranging alarm, bitrate high. We can see S-band receiver alarm is turned on right now. It'll be cleared in a moment. We'll test the glycol pump handover. So pump 1 is open. We can see the pressure drop. And pump 2 engages entirely automatically. We'll go ahead and test the secondary pump. instrumentation only pump. Looks good. Looks good. Auto transfer is used for critical parts of the mission, but it's not a system that remains powered all the time. VHF-B activation. I think that is supposed to be a checklist. So let's go ahead to nav and come down to VHF-B activation. They just forgot to link it. So VHF-B transmitter will be voice. Receiver on. This is why it's good to know the checklists. Even if the system has issues. Forward. Go. Transceive. Transceive. Good. Okay. Verb 74 will be an erasable memory dump down to mission control. And there we go. So, any questions about the power-ups so far? We're looking directly at the surface of the moon at the moment. Okay. So, circuit breaker comms, systems engineer open, telemetry biomed off. And let's go ahead and transfer the lunar module pilot over to the command module. The lunar module pilot will disconnect the O2 hose, and while that's happening, we will perform the preferred IMU alignment here. We are about to torque the IMU, so we need to get off of attitude control. Okay, so we're looking for 117.78. $231. .4. And yaw will be 9.67. It's a very, very small correction to be made. Super tiny. And that's it. That was the correction. Now we'll go ahead and make an even smaller correction. Yeah, we were already on the landing site refs, Matt, but we're just doing a small refinement of it, if you will. And now we're doing... So we did a coarse refinement of, like, literally less than a degree. And now we're doing the pulse torquing to get it perfect, down to within 1/10,000th of a degree. And that's it. That tiny little twitch you saw there, that was what all that was for. There you go. Yeah, it's not perfect, but it's good. Okay. VHF checkout. CSM configure VHF for VHF-B simplex. Okay. VHF-B is simplex. Voice check. Voice check is good. CSM configure for VHF-A simplex. VHF-A simplex is configured. Voice check. Voice check looks good. Okay, LGC clock sync. Verb 25, noun 36, enter. Verb 06, noun 65, enter. So we're at 97, 16, 41.21. $97, 16, 41.21. Verb 06, noun 65. Okay, now both people have to hit enter at the same time. So 5, 4, 3, 2, 1, mark. Okay, so we are now at 17.1 or excuse me, 17:1.59. Command module is at 17:30.35. So we need to increment by 28.76 seconds. So verb 55. Okay. So 97, 18, 39, 87, 39, 86. Yep, that's good. It's as close as she can get. Back to CM. Give us a verb 05, noun 01, and a 1706. We'll get our time of ephemeris moved over. Okay, looks good. That should successfully hand over most of the guidance program. And timing, that is, it's all timing. Just all the timing transferred over. And the very last thing we'll need to do is the docked IMU course align. And that'll be pretty much everything required for the command module computer to give to us. Any questions so far? Yeah, it's unfortunately nighttime at the moment. Yeah, hopefully not all that is super confusing. It's pretty replicatable if you just have someone see how it's done, but power up in the lunar module is like my absolute favorite part of this mission. Aside from maybe lunar entry is also very good. Okay, CSM is in a minimum deadband hold. So we're looking for 300 minus roll. So 300 minus 120.17. We're looking for 180 plus pitch. And 360 minus yaw. How many amps is the lem drawing right now? I'll get that to you in a little bit. Setting the ref's map flag now. Bit 13 is set. And now we'll use P51 to generate the drift flag. Drift flag is set. And the angles look good. Okay. Yep. Okay, so S-band antenna, pitch to 90, yaw to 0. Slew. Pitch to 165. Yaw to 66. Minimum deadband hold no longer required. Go ahead and disable roll jets. And intervehicular transfer to the lunar module. Lunar module pilot, suit flow. Power umbilical is in. Okay, LCG pump closed. CDR and LMP will now move to their suits. And we will close the hatch. Overhead cabin dump valve to auto. Pressure regulators to cabin. And we'll do the hatch integrity check. Yeah, I'll get to that question in just a moment. We're just a little bit crunching on time right now. Okay, while we're venting, I'll get you an answer. So, the current amperage that we are drawing from the batteries is going to be... They do not charge the LEM batteries. They only supply power so that the batteries don't drain. It is possible for the lunar module batteries to charge the CM batteries, but it is not possible in the other direction. They don't charge. They just keep them. They just keep them from draining. So it's going to be that, plus that, plus that, plus that. Since we have balanced loads, all the batteries are equal loads. So let's say that that's 5, 10. Then it's a weird scale. Let's take a look at this real quick. Okay, a little bit more. We can go ahead and load up. I've gotten telemetry, actually. Ground station telemetry. So we're looking for... Lunar module telemetry client. And we're looking for... Not that. There we go. Ground tracking station. Connect. So currently on low bit rate, but we're actually LOS right now, so I can't actually see the data. But before we went loss of signal, which was actually before we equalized the load, it's going to be a total of... total of 31.06 amps pulled from the batteries. Okay, there we go. This should be constant. Yep, so hatch integrity looks good. Let's go ahead and vent the rest of the way. Install docking target. Yeah, the procedure to get the command module batteries to charge is like literally insane. There's so many sneak circuits you wouldn't really expect power to go backwards that way through completely seemingly unrelated systems. But there's a way. Okay, Ascent battery checkout. Ascent ECA control closed. Yeah, and it's a whole nother game in here than it is in reentry, obviously. Bat 5 enabled. System engineer bus. Bat 6 enabled. 1, 2, 3, 4. 0, 0, 0, 0. CDR. SE. Backup. Backup. Normal. Normal. CDR. SE. Voltage is stable. Battery current looks good. Looks good. Suit gas return to egress. Suit circuit relief closed. Pressure regulator A closed. B direct. We're tanking up the suit pressure now. We're doing a PGA integrity check. So PSI should be decreasing less than 0.3 per minute. Yep, that looks good. And if we select secondary, we should see CO2 component light on, reminding us the secondary is engaged. And the same thing, less than 0.3 per second. And it looks good. Okay, back to primary. Suit circuit relief to auto. You should see the pressure begin to drop as it dumps into the cabin. Cabin gas return auto and push. Okay, cabin gas return to egress. Pressure regulator B to egress. Forward cabin dump valve open. Verify auto repress. Looks good. Regulator A, close. Cabin repress, close. Forward dump, open. Pressure regulator B to close. Suit circuit relief, open. Okay. Suit circuit relief to auto. Verify no suit repress. Okay. Pressure regulator B to egress. Verify suit repress. Good. Cabin repress to auto. Verify no cabin repress. Good. Pressure regs to cabin. And verify cabin repress. Good. Cabin gas return to auto. And push. We can transfer the crew back to the cabin. Switch to the CM. That's chilly. Yes, the reason it is so cold is because we were just dumping fresh oxygen into the cabin, so it is going to be very cold. But additionally, the crew were in their suits for quite some time, which means the cabin was isolated. So yeah, it's going to be really chilly. Alright, so that would complete the pressure regulator checkout. So the suit integrity is really good. The cabin's ability to maintain pressure is really good. Suit's ability to maintain pressure is really good. And now the last things that we need to do is we're actually going to perform a landmark tracking at some point. But we're going to update the lunar module on their DAP load and their gyro torquing angles. So yeah, I think we may possibly end it here. Not sure, though. I think we'll go a little bit longer. We can go right up to that landmark track. There we go. They're on a photo. Alright. Enable some roll jets. Make our maneuvers. Let's go Omni Charlie. Okay, we can go ahead and do the rate gyro check after the CSM has stabilized its attitude. I'm gonna go refill my cup of water while we're making our maneuver here. Okay, got my water refilled. Alright, CSM holding at. Ooh, that's pretty. 1 second. Take a stop to smell the roses. Okay, there we go. Let's go ahead and do our test of our gyro here. Our rate gyros. Okay. Eggs activation time. Stabilization control, AEA. Close. Circuit breaker AC bus B, eggs close. Eggs to operate. Caution warning reset. Good. Clear. 1, 2, 3, minus 4, 5, 6, 7, 9. Good, all the keys work. 4, 1, 2, plus 1, 2, 3, 4, 5. Egg self-test is still running. There we go, satisfactory. Good. 574 should be plus 0 for not staged. 604 should be plus 0 for not on lunar surface. And 612 should be plus 0 because we have not fired any explosives yet. Okay, telemetry biomed, right. And let's go ahead and generate the lunar module digital autopilot pad and our LEM gyro torquing angles. These are super easy to calculate. So weight is plus 33773 plus 37735 plus 006.08 plus 006.98, and then the gyro torquing angles, those are done through this menu. There we go. And our gyro torquing angles are minus 0.157 plus 0.086 plus 0.128. We can go ahead and do landmark tracking. Okay, coming up on T2, which is 96, 50, 46. Oh, hold on. I forgot I needed to get that for our current 98, 49, 02. Okay. We'll go on for just a little bit longer, doing some landmark tracking coming up, just a touch of time skipping. Okay, landmark will appear at the horizon at the 43 minutes 56 seconds. About 3 minutes later, 4 minutes later that is, we'll get it at the T2 point. So we're coming around the bend, starting to become perpendicular with the lunar surface as we maintain our inertial attitude. You can see optics is tracking. Okay. Pitching down at 0.3 degrees per second. We'll try our best here. Can't really see anything though. Okay, let's see how that is. Okay, landmark tracking's complete. We'll now continue our pitch down to our eggs calibration attitude here. We can see the pitch down looks very suspicious in the lem. It actually is imparting lots of roll. All right. Just aligning our high gain antenna. There we go. All right, let's get in our IMU final line now. And there we go. That little tiny pulse, that was it. Looking good. Okay. And that's it. I think we're gonna stop here. Because we need to get the pippa bias, LGC abort constants, and I'm not sure how to do all of that. So I think we're gonna stop here. We'll make a save. So yeah, I'll figure out how to do all of that, and then we'll be pretty set. Yeah. The eggs K factor, I already know how to do. I'm not sure how to do the eggs abort constants or anything like that. And so we'll have to stop here. Um, I could deploy the landing gear now. However, that would immediately throw me into rushing to figure this stuff out. So we're gonna wait like a couple minutes before landing gear deploy. We're at 990211. We could see landing gear deploy, which is a hallmark of a powered up lunar module, is at 9905. And then we are into all of that shenanigans. As you can see, there's quite a lot. The clock sync should be pretty easy. There is just one for time increment right here. The lunar module and command module state vectors, that's pretty easy. Pippa bias, uh, not exactly sure how to do that. So yeah, I'll ask all of that, and it should be pretty good from there on. After that, we'll turn on the eggs completely, not just like powered up, but we'll, key in all the data. Gap set and gimbal throttle test is my absolute favorite. And then we'll begin using some of our explosives, pressurizing the RCS, checking out the RCS, pressurizing the descent propulsion system, all of that, and then we'll go into undocking. So we're sort of about 90% of the way done with LEM activation. So hope that was fun, and I'll see you all later. Yeah, thanks for stopping by. Glad you enjoyed.